Assalamualaikum and good day everyone. So this is our last subtopic for this chapter. In this video, I'm going to explain to you on how to solve an odd function. So refer to this example here. You are given a periodic function f(x) which is defined as this one. Okay, so for the first question, you were asked to sketch the graph and determine whether the function is odd, even, or neither function, and state a reason. So I hope by now you are able to sketch the graph and you will have this one. You will get this one. Okay, so clearly based on this graph, this is an odd function since it is symmetrical about the origin. Okay, so now we are going to find its Fourier series expansion for that function. Okay, so since it is an odd function, it is symmetrical about the origin. Okay, so this is just the same as even function. We consider the positive part, which means from 0 until L. Okay, so that's why this one here, you are going to integrate from 0 until L, and you're using 2 over L. Okay, for odd function, a naught is equals to 0, an is equals to 0. You don't have to calculate for your a naught and your an. You just state a naught is equals to 0, an is equals to 0. For even function, bn is equals to 0. Okay, so that's why sketching is very important. If you sketch wrongly, then you will define your graph wrongly. So then you will use the wrong equation to get the Fourier series expansion. Okay, so for odd function, we just have to calculate for your bn only, because your a naught is equals to 0 and an is equals to 0. Okay, so by referring to this periodic function, we can get our L. So in this case, your L is equals to 1. Okay, your L is equals to 1. Then you can state your a naught is equals to 0, your an is equals to 0. So a naught is equals to 0, an is equals to 0. Okay, so now your bn is equals to 2 over L, so 2 over 1, integrate 0 to 1, fx sine n pi x dx. Sine n pi x dx. Okay, since your L is equals to 1. Okay, so take a look at your periodic function here. Your interval or your range is from -1 until 1. But since it is an odd function, okay, and we consider the positive part, so you need to start from 0. So your lower limit will be 0. Your upper limit here will be your L. So in this case, your L is equals to 1 because you just have one function. So you can directly take this one. Okay, so therefore you will have 2 integrate 0 to 1 x sine n pi x dx. Okay, so again here you are dealing with tabular method since it is a combination between polynomial and trigonometric function. Okay, so therefore, so this is your tabular method. So you're going to differentiate your x and integrate sine n pi x. Okay, so differentiate x, you will have 1. So differentiate sine, negative cos n pi x over, so differentiate the argument inside here, will give you n pi. So over n pi. Okay, remember you cannot cancel out this one and this one. Okay, you cannot do that. Why? Because this n pi is not in this bracket. Okay, So the last one is 0. So again differentiate cos n pi x. So you will have sine n pi x. So negative is still here over. So you will have another n pi. So n pi multiplied by this n pi will give you n pi the whole thing squared. Okay. So therefore this is your tabular method result. Okay. So your Bn is equals to 2, which come from this one here. So you have negative x cos n pi x over n pi minus will give you plus. So plus sine n pi x over n pi the whole thing squared. So your upper limit is 1, your lower limit is 0. Okay, so now substitute the limit. So first we are going to substitute x is equals to 0 right into here and also here. Okay, so you will have negative cos n pi over n pi plus sine n pi over n pi the whole thing squared. So this is upper limit minus, so what is your lower limit? So your x is equals to 0. So when you substitute here, since your x is equals to 0 here, 0 multiplied by any other function will give you 0 plus sine 0 over n pi the whole thing squared. Okay, so now we are going to simplify what you have here by using this one. Okay, so therefore you will have, so this one you can simplify, so you will have negative 1 to the power of n, sine n pi is equals to 0, sine 0 is equals to 0. So therefore your Bn is equals to negative 2 negative 1 power n over n pi, or you can write it as Bn is equals to 2 negative 1 n plus 1 over n pi. Okay, you can either stop here or here, but if the question asks you to prove that or show that your Bn is equals to this one, then you have to get until this one. If not, you can just leave your answer up till here. Okay, so now you already have your Bn and you know that your A naught and your An is equals to 0. So based on this Fourier series expansion here, when your A naught is equals to 0, your An is equals to 0, so you just left with this one. So your Bn, this is what you just calculate just now, multiplied by sine n pi x, since your L is equals to 1. If your L is equals to 2, then you substitute 2 here. Okay, refer to your L. So therefore, your fx is equals to summation n is equals to 1 to infinity. You must write this one because we are considering n is equals to 1 until infinity. Okay. So what is your Bn? 2 negative 1 n plus 1 over n pi multiplied by sine n pi x, since your L is equals to 1. So therefore this is your answer. Okay. Okay, now let's proceed with the second example. So you are given this periodic function. Okay. So for the first two questions, you should be able to sketch the graph within the range of -2 until 2. So you should get this graph. Okay, so based on this graph here, you can conclude that this is an odd function since it is symmetrical about the origin. Okay, so now, okay, if you take a look at this graph here, the graph will repeat itself after this period of L. Okay, and as you can see, this is not a complete graph and this is also not a complete graph. Okay, so it's okay, you just have to follow the question. Okay, so if the question asks you to sketch between this range, then you just follow this range. Okay. Okay, so now we are going to find the Fourier series expansion for this function. So again, you need to identify what is your L. Okay, so as you can see here, your L is equals to 1. Okay, and since this is an odd function, clearly you know your A naught is equals to 0, your AN is equals to 0. So therefore, you will directly write A naught is equals to 0, AN is equals to 0, and your L is equals to 1. So by using this formula here, we are going to find Bn. So Bn is equals to 2 over L. So 2 over 1 is equals to 2. So integrate 0 until 1, fx sine n pi x, since your L is equals to 1. Okay, so take a look at your periodic function here. You need to find where is the value of 0. Refer to which interval, either this one or the second one or the last one. Okay, so if you take a look at the second function here, for the interval for the second function, you have -half and also half. So in between this value, you will have 0 here. Okay, since it is an odd function, so you can start to integrate from 0 until L because it is symmetrical. Okay, so if you take a look here, 0 here is in the second function. Okay, so therefore, you are going to integrate. So 2, so your lower limit is 0. So for the second function here, you need to start from 0, although this is -half. Okay, why? Because it is an odd function, so we consider the positive part. Okay, because it is symmetrical. Okay, so we start from 0. So what is the upper limit here? 1 over 2. Okay, why you need to split this function? Because you have two functions here. Okay, in the previous example, you just have one function. So that's why you can directly write your limit 0 until 1. Okay, but for this problem, you need to split because you have two functions. Okay, so this one is not included anymore. Why? Because we consider 0 until L. Okay, so therefore you will have 0, 1 over 2. So what is the function? -2x sine n pi x dx plus 1 over 2 until 1, -2 sine n pi x dx. Okay, so please check before you proceed with the integration. Please check. So your upper limit is 0. Your lower limit is 0. Your upper limit is 1. Okay, and in between this should be the same value. Okay, so for this part here, you need to apply tabular method. But as for this one, this is direct integration. Okay, so let's just proceed with tabular method first. So you are going to differentiate. You are going to differentiate negative 2x, and you are going to integrate sine n pi x. Okay, so differentiate negative 2x will give you negative 2. So integrate sine will give you negative cos n pi x over n pi. So the last one is differentiate negative 2, you get 0. So again, when you integrate cos, you will have sine, so negative is still here. Over, so over n pi, so n pi multiplied by this n pi will give you n pi the whole thing squared. So therefore, your Bn is equals to, so please remember you have this value in front here. Okay. So therefore, your Bn is equals to 2. So for the first function here, we refer to this tabular method. Okay. So you will have negative will give you positive. So you will have 2x cos n pi x over n pi. So minus plus minus, you will have minus 2 sine n pi x over n pi the whole thing squared. So this is for the first function. So for the first function, the upper limit is 1 over 2 and the lower limit is 0. Plus, okay, for the second function, this one. So this is direct integration. So integrate sine will give you negative cos. So negative, then you will have positive. So you will have 2 cos n pi x over n pi. Okay. So what is the upper limit is 1 and the lower limit is 1 over 2. Okay, why the negative sign here? This one here you have a negative sign, but down here you have a positive sign. Because integrate sine you will have negative. So negative multiplied by negative will give you positive. Okay. Okay, so now we are going to apply upper limit minus lower limit. So therefore your Bn is equals to 2. So for the first function here, we substitute x is equals to 1 over 2. So you will have 1 over n pi cos n pi over 2 minus 2 over n pi the whole thing squared sine n pi over 2. So this is the upper limit minus with the lower limit. So now we are going to substitute x is equals to 0 right into here. Then you will have 0. And this one into here. So you will have 0 minus 0. Why? Because sine 0 is equals to 0. So the whole thing becomes 0. Okay. So settle with the first function. Plus, okay, for the second function, which is this one. So the upper limit is 1. So substitute x is equals to 1 will give you 2 over n pi cos n pi minus 2 over n pi cos n pi over 2. Okay, so now we are going to simplify the function by using this one. Okay. So you will have this one, cos n pi is equals to negative 1 power n. Okay. For cos n pi over 2 or sin n pi over 2, you don't have to do anything. Okay. Unless if you have a negative sign inside here or negative sign inside here, then you have to simplify. Okay. Okay, so now your Bn is equals to, okay, for this function and this function, you can simplify because this is the same function, right? So 1 minus 2 will give you negative 1. So you will have negative 1 over n pi cos n pi over 2 minus 2 over n pi the whole thing squared sine n pi over 2 plus 2 over n pi negative 1 power n. Okay. So you can substitute the value of 2 into this one. So therefore, your Bn is equals to negative 2 over n pi cos n pi over 2 minus 4 over n pi the whole thing squared sine n pi over 2 plus 4 over n pi negative 1 power n. Okay, it's okay if you end up your solution with long equation. Okay, as long as you already check and that is correct. Okay. So now you already have your A naught because your A naught is equals to 0, your AN is equals to 0, and you already calculate your BN. So you can substitute into your Fx. So this one is 0, this one is 0, so you left with this one. So therefore, your Fx is equals to summation n is equals to 1 to infinity negative 2 over n pi cos n pi over 2 minus 4 over n pi the whole thing squared sine n pi over 2 plus 4 over n pi negative 1 power n multiply by sine n pi x since your L is equals to 1. So this is the final answer. Okay. So guys, we are done with this chapter. I hope by now you are able to understand Fourier series well. So please try to do the exercise in your notes, and if you have any problem regarding the exercise, please let me know so that I can guide you to get the answer. Okay. So thank you. Assalamualaikum.